All right, let's do this. Okay, welcome back to Math 160. And Suraj, no worries, that sounds great to me. So we are going to pick up where we left off, page 15. So let's take a sneak peek. We started practice problem number 6, looking at the given information to first determine if we actually have a binomial distribution. We classified this by saying we noted that there are repeated trials, right? There are 4 of them. We were looking at 4 houses, and we were examining the probability or the likelihood that they would have high levels of radon gas. We noticed there were 2 outcomes. Either they did have it or they didn't. The value of P, which is success, is 0.65. And now reason being, notice we have 65% of all homes in a certain county have high levels of radon gas leaking into their basements. So success in this case is, do they have radon gas leakage? We're told the probability is 65%, so we write it as a decimal. We know that if P is 0.65, Q, the probability of not having high levels of radon gas, is 0.35. It's whatever's left. We know that when we combine these, we get a total probability of 1. I then wrote our formula for calculating the probability of a specific value as n choose x. This is combination, n choose x. The probability of success raised to the number of successful outcomes times the probability of failure raised to the number of failed outcomes. For part A, we wanted to find the probability that exactly 2 houses were found to have radon gas leakage. So that's when the random variable takes on the exact value of 2. So we say out of the 4 that we have, right? N is 4, that's the total number of houses that we're looking at. Out of the 4 houses, we choose 2 of them to have radon gas. So the probability of success raised to the 2, because there are 2 houses that have it, and the probability of failure raised to the second power because there are 2 houses that don't. So we're essentially trying to say, what's the likelihood that exactly and only 2 of the houses have the leakage? And we found that there's a 31.05% chance. So now we're ready to look at part B. This says, what is the probability that at most 1 house was found to have a radon gas leakage? Anyone throw this out there? What do we mean by at most 1? What does that imply?
Less than or equal to 1?
Yes, less than or equal to 1, which means that we want to find the probability when no houses have radon gas leakage. And we also want to find the probability when 1 house has radon gas leakage. So we actually have to find them separately. It's going to seem like a lot of work, but it really isn't, because it follows a nice flow. So I'm going to write out the probability that x is equal to 0, exactly 0 houses. We're going to apply the formula here. We had 4 houses to begin with. I'm going to choose 0 of them to have radon gas leakage. We know the probability of success is 0.65, but we're saying that 0 of them will have the leakage. The probability that there is no leakage is 0.35, which means the rest should not, right? So out of the 4, we choose 0 to have gas leakage. That means the other ones do not. 0 here, 4 here. There's only 4 houses total. So go ahead and punch this into your calculators, get that practice, and see if you can find the values. We learned last class that we can simply use our calculators and this PRB button. So we would type in 4. I'd press PRB, go over to NCR because this is a combination. So think 4, choose 0. That's what I'm looking for. 4, choose 0. It's actually just 1. So we take 1, we multiply by 0.65 to the 0th power, which, by the way, anything to the 0th power is 1. So it's still going to be a 1. And then we multiply by 0.35 raised to the 4th power. And there's my probability. So we're going to write 0. Let's go 3 places, 0, 1, 5. But we're not done yet. If the question asks, what is the likelihood that no houses, Ava, we did have class Monday. What is the likelihood that we have no houses with radon gas leakage? We're going to say there's a 1.5% chance that that happened. But we want to know the probability that at most one was found to have the leakage. So let's also find the probability of exactly one. Same thing, I'm going to move a little quicker. 4, choose 1. One house is going to have the gas leakage. So we raise 0.65 to the 1, which means 3 houses are not going to have it. You see, out of the 4 houses, 1 does and 3 do not. Let's go ahead and punch this into our calculator. 4, choose 1, multiply that by 0.65 to the 1st power, and then multiply that by 0.35 to the 3rd power. Would someone share what they are getting for the probability when x is equal to 1? And
0.111475.
yes, excellent. So what I'm going to do is I'm just going to round to the nearest thousandths place just to be in line with the previous answer. So 0.111. Just to showcase how to do this again, you're going to type in the number 4. Then you're going to press your PRB button on the calculator. Go over to where it says NCR because you're choosing. We're going to choose 1 this time. Press enter. After that, you just have to multiply the rest of it. So 0.65 to the 1st power, and then times 0.35 to the 3rd power. And there you have it. Okay, Donna, hopefully that helps. Let me know. To find the probability that at most one house was found to have the leakage, so x is less than or equal to 1, exactly what Jenny said, all we have to do is add these 2 probabilities. So 0.015 plus 0.111, that's going to give us a total probability of 0.126. Would somebody tell me the accompanying statement for this problem? Whenever you're ready.
There is a 12.6% chance that at most one house has radon gas leakage.
Yes. Yes, that's perfect. There's it. And who was that? Who was just speaking right now?
Nicole.
Nicole, thank you. I'm so sorry.
It's okay.
Thank you. There's a 12% chance. It's hard, you know, because you can't see all the screens at the same time. There is a 12.6% chance that at most one house has radon gas leakage. Nicole, thank you so much. You're absolutely correct. And that was perfect. Beautiful. What questions do you have for me on this problem? It was interesting because we ended up having to calculate the probability twice, right? For 2 different instances.
I have a question.
Yeah.
How did you get the 3? Do you see like right here on the second one? Yeah, how did you get that 3?
Think about it like this. We have 4 houses total, right?
Mm-hmm.
So I'm saying one of them will have the gas leakage. How many won't?
3. Okay, so you just subtract?
Yes, yes.
Okay.
Let's look at the formula really quickly. The formula states we're going to take the total number and we're going to subtract that x.
Oh, okay, I see.
It's what's left over. So if you had 4 houses and you're going to say, what's the probability that 3 of them have the leakage? And you can say, well, 1 of them won't.
Okay,
Good.
thank you.
You're very welcome. Any other questions for me? Okay, let's turn the page when you're ready then. Practice number 7. Because we're employing the exact same concepts, I think I would love for you all to try this in groups, but let me give you some advice on practice number 7 before you start. Recall that you want to make sure that you are noting the probability of success. What is success? The probability of failure. You also want to know how many repeated trials there are, your N, your total number of items in your set. So I'm going to put you into slightly larger groups just to make sure that we're all communicating with each other and being willing to say, if I'm not sure and this next person isn't sure, there's gotta be another one who's like, okay, I think I have the right idea here. So let's create groups of, let's do 6 participants per room. So make sure your mics are on so that way you can communicate with one another, okay? No silent groups. It doesn't make sense to do that. It's not very fun. All right, I'm going to create these and open these up. Enjoy. I'll call you back in a couple minutes. Make sure you finish A, B, and C. Okay, so when we examine practice number 7, the first thing we notice is that the probability of success is 0.87, right? 87% of all Americans have cell phones. The probability of failure would then be 0.13. It's what's left over, right? Out of 100%, 87%, and 13%. Find the probability that in a group of 23 randomly chosen people, which means that N, the total number of people I'm surveying, or analyzing, or just questioning, is 23. So for the first one, we want to find the probability that exactly 19 people will have a cell phone. So let's write out our probability the appropriate way. We have X is equal to 19. We know that we start with the total number, which is 23. We're going to choose 19 of them, right? 23, choose 19. 19 of them will have a cell phone. So we're going to say 0.87 raised to the 19th power. And then the probability of failure is 0.13. If 19 of them have a cell phone, that means that 23 minus 19 is 4. 4 of them won't. When you punch this into your calculator, you should have had 0.179 as your probability. You're then going to comment that there is a...
Is it okay if we rounded to the 4th decimal place?
Yes. Oh yeah,
Okay.
absolutely. So what did you have? Let me see. What did you end up with?
1794.
Ah, yes, 0.1794. So you would say there's a 17.94% chance. Yes, that is totally cool. So there's a 17.9% chance that exactly, notice the language that we're using. I want you to get used to this. This is how you would respond in an application problem if you were asked. That exactly 19 people will have a cell phone. Perfect. Would someone else take the lead on part B? At least 22 people will have a cell phone. Donna, I would just double check your values, make sure it's 23, choose 19, and then make sure it was 0.87 raised to the 19th and 0.13 raised to the 4th. Mallory, absolutely, absolutely. So yes, someone else take over for part B, that at least 22 people will have a cell phone. What does that mean?
X will be greater than or equal to 22.
Yes. So essentially, we want to find the probability that X is greater than or equal to 22, which implies we have to find the probability when our random variable is 22. We find the probability when our random variable is 23, and we add those two together. That's perfect. So we're going to go ahead and write those probabilities. So notice we have 23 total, choose 22. 22 of them will be a success, so 0.87 to the 22nd power. So if 22 of them will have a cell phone, then only one of them will not, okay? When you punch this in, you should get something along the lines of 0.140, and you can add anything or subtract anything if you'd like. in terms of rounding. And then we want to find the probability that 23 individuals have cell phones. So 23, you're going to choose 23. All 23 of them will be successful, which means that there will be no one without a cell phone. The likelihood that this is happening is 0.041. It's pretty unlikely that every last person in that group is going to have a cell phone based on the data that we were given.
I did 0.1397 and then 0.0406.
0.0406? Yes.
Yeah.
That works too. Yep, that totally.
Okay.
So in which case, the total probability was around 0.181. Did you find that?
1803.
1803. Okay, yeah, that's pretty close. We're only going to have a slightly different because of the place in which I rounded.
Should we round to the third decimal place from now on, or does it matter?
So this is the conversation I love having, and it's, you're the statistician in the moment. So if you feel that you want to be more accurate by including 4 places after the decimal, that's awesome. You're actually going to be more accurate than I am. Your answer is more accurate than mine. It doesn't mean that either of us are wrong. It's just one is closer to the true value than the other. But then someone else can round to 5 places. So you're the statistician in the moment. So go with what you think is appropriate unless specified otherwise. Okay.
Okay. Thanks.
You're welcome. We combine those two, add our 2 probabilities. That gives us 0.181 approximately. So there is an 18.1% chance that at least 22 people will have a cell phone. Cool, I love it. Now, what in the hell do we do for part C? That at most 22 will have a cell phone. My first question before we get into like how you dived into it, what does that even mean, at most 22?
22 and everything below it.
Yeah, 22 and everything below it. So wait. You mean 0, 1, 2, 3, all the way to 22. Yikes. So you could find the probability of 0, the probability of 1, the probability of 2, all the way to 22, which would probably make you hate everything around you. Or you can use a different strategy. Sam, would you please share with us the strategy that we should employ for this particular problem?
You just find the probability that it's 23 and then subtract that from 1.
Yes, perfection. So I'm writing here that at most 22 means all the probabilities from 0 to 22. But what that means is that 23 is excluded from that group, right? It's the only one that's excluded from the group. So Sam says, let's be creative. What we're going to do is we're going to actually find the probability of exactly 23, because that means I just have to take this probability away from 1, which is total probability, and that's going to give me everything else. It's such a neat way of calculating that probability from 0 to 22 without having to find each and every single one of those probabilities. That would just take way too long, unless you had some sort of computer software, which I'm going to show you. So anyways, so we want to find the probability that at most 22, so less than or equal to 22, that's going to be the same as taking 1 and subtracting the probability of exactly 23. I hope that makes sense to you. Now, the super cool thing is we actually already calculated the probability of exactly 23 in part B. There it is. So the probability of exactly 23 is 0.041. So we're going to take 1 and we're going to subtract 0.041. When you do so, you should get 0.959, which actually makes a lot of sense. The chance that at most 22 people will have a cell phone, that's going to be 95.9% chance. So let's write that out. As I'm writing this statement, if you have a question, please ask. Did every group get this?
Yes.
Nice. A cell phone. Perfect. That makes me very, very happy. So there's a 95.9% chance that at most 22 people will have a cell phone. Beautiful. Let's turn the page, and I want to show you a binomial probabilities table that you actually can use. Or if you don't want to use the paper table, we can actually use online software, and I'll show you that as well. Because really, when you think about it nowadays, how often are people using tables like this to calculate anything, really? I mean, we're going straight to computer software. We just are. That's the reality of 2021, right? Okay, but let me teach you what I have to teach you, and that is how to use this table. Let's look at an example. In California, 30% of the people have a certain blood type. Okay, so consider that a success, having that specific blood type. So I'm going to write that P is equal to 0.30. What's Q? Anyone?
Failure.
And what's the value?
0.70.
0.70.
0.70. Very nice. What is the probability that exactly 3 out of a randomly selected group of 5 Californians will have that blood type? So we know that N is equal to 5. So essentially what we're saying is, if we want to find the probability that exactly 3 have that blood type, we'll do 5, choose 3, times 0.30 probabilities of success raised to the third power, because that's going to be 3 of them, which means how many will not have that blood type?
Two.
Two.
Yes. 2 of them will not. Now, instead of punching this into your calculator, I want to show you how you could just use the table. Do you see across the top here represents all of your different P values? Now, notice it doesn't take into account the ones in between. So we can only use this particular table for these specific values, a P value 0.05, 0.10, 0.20, 30, 40, etc. So this is not totally helpful at all, actually, because you're so limited. But in this case, we know that P is 0.30. Next, notice this first column shows us the N value. So we know that N is 5. So we're going to go to where it says N is 5. So we've got, and I'm going to highlight. Right now we're looking at when N is 5 and the probability of success is 0.30. So that means we're looking at this group of values. So I'm just going to highlight this group of values so that we have it readily like on our minds, basically. If we want to find the probability that exactly 3 have a specific blood type, then we're doing 5, choose 3, right? Now, the cool thing about this table is it's already calculated. So 5, choose 3, you go over to where 3 is, and you see that the probability is 0.1323. Now, to prove it, I'm going to punch this formula into my calculator. 5, choose 3 times 0.30 to the third power times 0.70 to the second power, and there it is, 0.1323. So it's neat. You have a table, you can use that. That's cool. And I don't mean to sound sarcastic, but I kind of am. So I want to show you how you would do this online. So let's go ahead and share this screen. I went into Google and I legit just typed into the search bar calculating binomial probability. You may want to write that down. Your search is calculating binomial probability. Now, that doesn't mean you just forget the formula. I mean, you should know the formula, but for large calculations, we can use this first link, stat trek. So binomial calculator instead of Star Trek, stat trek, clever. We'll go ahead and click that. And now check this out. So this is your binomial probability calculator. So it says enter a value in each of the first 3 text boxes, the unshaded ones, and then you could calculate, and then it'll give you all the probabilities. So check this out. So the probability of success we said was 0.30. The number of trials we said there were 5, and we want exactly 3 successes. So I punched in those 3. Now I click calculate. Check it out. So the probability that you get exactly 3 successes is 0.1323. That's what we did together. Let's read what this one implies. I'm going to annotate the screen so that it's a little bit clearer for you. Notice it says the probability that x is less than lowercase x. This means the probability that x is less than 3. What that means is 0 outcomes, 1 outcome, 2, and that's it, not including 3. If we had to do 0, 1, and 2, we would add those 3 probabilities together and it would give us 0.83692. This next one is going to be the same exact value except equal to 3, so less than or equal to, so it's 0, 1, 2, and 3. That gives you the probability using binomial distribution. This one is the opposite. If it says the probability that x is greater than 3, that implies we want to look for values of 4 or 5, right? We want to find those probabilities and add them together. It did it for you. It did the math for you, 4 or 5. For this one, it's x is greater than or equal to 3. So that's going to be 3, 4, and 5 as well. So this is a pretty cool website that will help you to calculate probabilities, binomial probabilities. So if you're ever in a situation where you're noticing that it's going to end up being a lot of work, a lot of adding, I would use this site, but I would also write down the information that you're given. Okay, still show the work, but then you can say the probability will be da, 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 da. Any questions on that? Cool. All right, let's turn the page. So let's actually just finish using the table. It says, what is the probability that less than 4 of a randomly selected group of 5 Californians will have that blood type? So the probability that our value will be less than 4. We know that that's the same as saying probability of 0, 1, 2, 3, add those together. So let's go to the previous page. We still want that highlighted block, but we want less than 4. So that means we're going to add these values together. We don't include the exactly 4 because it's less than 4. So we just want to add all 4 of these values together. Go ahead and take your calculator and add those values together. Make sure you're doing this very carefully. And what are you getting for your decimal?
0.9693.
Yes, perfect. Very, very nice. If I go back to that calculator that I had, I changed the number of successes to 4 because we want the probability that x is less than 4, and here it is, 0.96922. So this is a little bit more accurate than our table, but it's exactly the same value. Okay, so 0.9693. Very nice. Cool, let's write that out. 0.9693. And then you know that you're going to make the statement that there is a 96.93% chance that less than 4 of the 5 Californians will have that blood type. Cool. Very nice. Very nice. We have a few problems that kind of just instill this idea. So I'm going to just call on people randomly, because I think that at this point, we have a pretty solid grasp of what's actually happening. We're going to use the table instead of write out the formulas. So you're gonna have to flip back and forth. So be willing to do that. Let's dissect practice problem number 8 first together, and then I'll just call on people randomly. So be prepared, okay? In a certain automobile dealership, 70% of all customers purchase an extended warranty for their new car. If you have 7 randomly chosen customers using the binomial probabilities table, find the probability ... Okay, let's start off with Mike. So Mike, I have some questions for you, and it's first, it has nothing to do with part A. Just looking at the word problem itself, what information do you have now? What does it tell you?
I would write P is 70 or 0.7,
Beautiful.
which means Q is 0.3.
Yes. Don't mind me adding the extra 0. It's just in case anybody's like, wait a second, what? But keep going. And then what else does this?
And then I think it would be N equals 7.
Yes, perfection. We have to start with those key pieces of information in order to even move forward. Mike, thank you so much. Part A, we want to find the probability that exactly 7 will purchase an extended warranty. So you're going to go to the previous page. You're going to look at the table. You're going to find the block of numbers where P, your probability of success, is 0.70, and where N is 7. So just to make sure that we are on the same page, here's the probability of success, 0.70. You're going to go all the way down to where your total number of trials is 7. So we're looking at, and I'm going to highlight it, we're looking at this block at the bottom. Perfect. Kelly, start us off. What's the probability that exactly 7 will purchase the extended warranty?
0.0824.
Perfection. Done. Let's write that out. Notice that exactly 7 is here. So 7, choose 7. 7's our last row. So it's 0.0824. Let's write out the correct notation. 0.0824. Very nice. Emma, part B, that at most 2 will purchase an extended warranty. First, Emma, what does that even mean, at most 2?
It includes 0, 1, and 2.
Perfect. Thank you so much. So if that's the case, when you look at the table, you want to add the 0, the 1, and the 2. So Emma, when you have a moment, once you've punched this into your calculator, would you provide to all of us the probability that at most 2 will purchase an extended warranty?
Yes, 1 second.
Yes, I love it. Nope, everyone else is doing the same thing, so take your time.
I got 0.1 or sorry, 0.0288.
Yes, 0.0288 is correct. 0.0288. Perfection. Thank you, Emma. Part C, the probability that at least 6 will purchase an extended warranty. At least 6. Let's go with Stephanie. At least 6. What does that even mean, first off?
Means that they could purchase 6 or less.
You're so close. At least means 6 or more. So you actually want to do 6 or 7. Perfect. So Stephanie, why don't you go ahead and take a look at the table? Look at the probabilities when X is 6 and when X is 7. Add those two together. I'm going to write out the statement. So at least 6 means 6 or more. So X is greater than or equal to 6. When you have that probability, go ahead and share that with the group.
For B, did you add all of them in the column?
For part B, I only added the probabilities of 0, 1, and 2, just those first 3 numbers.
Thank you.
You're welcome.
So 6 would be 0.471 or 0.2471,
Yes,
and 7 would be 0.0824.
yes, perfect. So when you combine those two, and you know what, I might as well just write that. So we have 0.2471, and you said 0.0824. That was a probability when X is equal to exactly 6, and the probability when X is equal to exactly 7. When you combine those together, what did you get?
I got 0.3295.
Perfect. Thank you, Stephanie. That is perfection. Very, very nice. And that's essentially the process of using the table. What questions do you have that I can help with? Okay, it sounds like this makes total sense. All right, so what I'd like you to do is I want you to answer practice problem 9 on your own. As soon as you are done with practice problem 9, I would like you to type into the chat your solutions for A, B, and C. Let's take a look at the website together so that we can make sure that we're understanding this. So the number of trials in this case for our problem is 8. We have 8 randomly selected people. And we want to notice for part A, it says, what's the probability that exactly 8 will say chocolate ice cream is their favorite? So go ahead and we change the number of successes to 8. So let's calculate. Perfect. And we want exactly 8. So this first value is actually going to be the probability. So let's go ahead and write for part A. I'm going to close this for one moment. For part A, we're going to say that the probability that your random variable is equal to 8, exactly 8 people. We know that that's the same as 8 choose 8. The probability of success is 0.30. The probability of failure is 0.70. I'm going to write here that n is 8. I know I'm writing the formula out, but I just want to show you how you can also verify this for yourself. So there's going to be 8 people who say that chocolate is their favorite, which means that's all 8. So there will be none that say that chocolate isn't their favorite. According to the website, we found that that likelihood is 0.000, one more 0, 6561. So AKA ridiculously low that that's even going to happen, right? We know that only 30% of Americans favor chocolate ice cream the most. So in which case it's probably really, really, really unlikely that all 8 will say that. Now, notice the next one says at least 2, right? So at least 2, what does that mean again? At least 2?
2 and up.
2 and up, 2 or more. So we want the probability that X is greater than or equal to 2. So 2 or more. So I'm going to go to the website again. And this time I'm going to change the number of successes to 2. Let's calculate. We want 2 or more. So the probability that X is greater than or equal to 2. That's the very last statement. X is greater than or equal to 2. That lowercase x gets replaced with the number 2. And that's exactly what we wrote down. So the likelihood that this happens is 0.74470167. Okay. So let's go over to our notes. I'm going to write exactly that down. What will help is your writing down of the inequality itself, because then you can match it to what you find on the website. So that probability is point, and let me go back for a moment. That's going to be 0.74470167. Notice it gives you so many places after the decimal, and that's okay. We're just way more accurate including those values. For the last one, at most 5. What does that mean, at most 5?
Everything below 5.
Everything below 5. Does it include 5, Surajni?
Yes.
So we would write that as a probability that X is less than or equal to 5. Go ahead and try this out now. Go back to that website, change the successes to 5, and then find the statement that shows exactly this value, exactly that inequality. Remember, you have to change it and then press calculate. And then when you have your value, text that to me in the chat.
Thank you very much.
You're welcome.
Have a great day.
You too. I'll see you Monday.
Okay.
Yes, I'm loving what I'm seeing. Yes, okay, score. Very nice. That is success. So you're getting 0.988707779. That's your probability that at most 5 will say chocolate ice cream is their favorite. That's perfect. That is perfect. How about let's make sure that everything is solid by doing this last question of the day, and we'll finish here. So practice number 10, in one of Mendel's hybridization experiment with peas, the probability of offspring peas having green pods is 0.80. Determine the probability that in a randomly selected group of 6 offspring peas that, and then do each of those. Remember how to start this problem. Write down the probability of success, write down the probability of failure, and then your N. That's going to help you out a lot. Okay, so we know that the probability of success is 0.80, which implies the probability of failure is 0.20. We know that we have 6 offspring P, so N is equal to 6. We want exactly 4. So the first probability statement we'll write is probability that X is equal to 4. We could use the table or we could use the software. I do want to demonstrate how we use the software because it's kind of fun. So we see that the probability is 0.80. We see that the number of trials is 6. And we want the number of successes to be exactly 4. Let's calculate. And there we have exactly 4 is 0.24576. So 0.24576, that's the probability. For part B, it asks for no more than 5. What this implies is 5 or smaller, right? No more than 5 is 5 or smaller. So we want the probability that X is less than or equal to 5. Be very, very careful with that. I'm going to go back to our software and I'm going to change the number of successes to 5. So we want to find the one that says X is less than or equal to that number. And here we have it right here. X is less than or equal to 5 gives us a probability of 0.737856. Okay, X is less than or equal to 5. Last one, we want the probability that at most 2, so that means 2 or smaller, right? At most 2. So we want that X is less than or equal to 2. At most 2, 0, 1, or 2. So let's go ahead back to that page. We're going to change the successes to 2. We'll calculate. At most 2, P is X. The probability of X is less than or equal to 2. And there it is, 0.2 01696. All right. Excellent work, everyone. Have a fantastic weekend. Make sure that you read my email. I'm going to send one in a little while. Okay. Bye, everyone.
Hi, thank